Hello students and welcome. Let's go ahead and take a look at some more examples from the homework in section 3.2 on conditional probability and the multiplication rule. And let's look at question 5. The problem says that the probability that a person in the United States has type B positive blood is 12%. It says that 3 unrelated people in the United States are selected at random. And we're going to complete parts A through D. Okay, so part A says find the probability that all 3 have type B positive blood. Okay, so the first thing we want to realize is that when we get our answer, we're going to want to round it to 6 decimal places as needed. So according to the problem, 12% of people in the US have B positive blood. So part A is asking us to find the probability that 3 unrelated people have that blood type. So the first thing we want to do is convert the percentage into a decimal. Right, that's because we're going to write our answer as a decimal. Okay, so we can use our calculators to do that. So some calculators have a function for converting percentages into decimals. So if you have that function on your calculator, go ahead and use it. Or use the fact that percent means parts per 100. So to convert a percent into a decimal, you take the number, in this case 12, and then divide it by 100. Okay, and you get the same result. So 12% as a decimal is 0.12. Okay, so to find the probability that 3 unrelated people have B positive blood, but what it's really asking, find the probability that the first person has that blood type and the second person has that blood type, and then the third person has that blood type. Okay, so we're finding the probability that the first person and the second person and the third person has B positive blood. So what that suggests is that we use the multiplication rule. Okay, so since these people are unrelated, okay, the fact that the first person has the blood type and the second person has the blood type and so on, right, does not affect the probability that the next person has that same blood type. So to get the answer, we're going to do 0.12 multiplied by 0.12 multiplied by 0.12. So we're going to multiply 0.12 by itself 3 times. Okay, so 0.12 times 0.12 times 0.12. Okay, and that's 0.001728. Okay, if you don't want to write all that out, 0.12 times 0.12 times 0.12, right, you can do 0.12 to the third power. So anytime you multiply the same number more than once, right, consider using the exponent feature on your calculator, right, and it'll give you the same result. Okay, so we're going to round that to 6 decimal places. So 1, 2, 3, 4, 5, 6. So the answer has exactly 6 decimal places. So we're going to type in the full answer as it is in the calculator. So 0.001728. Okay, so now we are asked in part B to find the probability that none of the 3 people have B positive blood. Okay, so this part of the question involves complements. Okay, we've talked about complements a little bit before. Okay, so if 12% of the population has B positive blood, okay, then what percentage don't have B positive blood? Okay, so you can just quickly do a mental calculation, right? So 100% minus 12. Okay, so we know that 88%, or 0.88, have don't have that blood type. So 1 minus 0.12 is 0.88. Okay, so the complement of having this blood type is not having that blood type. So it's simply 1 minus 0.12, which is 0.88. Okay, so the probability that all three do not have that blood type would be 0.88 times 0.88 times 0.88. Okay, which is equivalent to 0.88 to the third power. Okay, so I'm going to go ahead and do that instead of multiplying that number by itself 3 times. So 0.88. Okay, to the power of 3. Okay, it's 0.681472. All right, and let's go ahead and enter that as our answer. Okay, and then pay attention to how many decimal places I want you to round it to. So it says 3 decimal places. Okay, so even though we have the right answer, it may be that we included too many decimal places or too few, but in this case we included too many. Okay, so the correct answer is 0.681. Okay, so you may know where this is going. So in part C, it's asking us to find the probability that at least one of the three has B positive blood. Okay, so we've done this before. So probability of at least one. Okay, if you think about that, what does at least one mean? So at least one means one or more. Okay, so if we have 3 people that we're selecting, right, at least one, right, means 1 or 2 or all 3 have B positive blood. So if you try to calculate it directly, right, by calculating 1 or 2 or 3, okay, that can get kind of complicated. Okay, so we're going to use that formula that we talked about in the previous video, right, which says that, okay, if we want to find the probability of at least one of something, right, it's simply equal to 1 minus the probability of none, right? So it's 1 minus the probability that none out of the 3 have B positive blood, okay? So the way that this is set up is that in part B, we've already figured out the probability of none. Okay, so we're going to take 1 and then subtract the probability of none from that, so 0.681472. So 1 minus. So the probability of none was our previous answer. So if you know how to access the previous answer in a calculator, go ahead and do that. Or type in the previous answer directly. So 1 minus that. So 0.3185. Okay, and I believe it wants that to 3 decimal places. So 0.3185 or 319. Okay, so first of all, right, so 3 decimal places. Okay, 8 is in the rounding position. Okay, so if the number to the right is 5 or more, let it soar. So that 8 is going to go up to a 9, so the answer is 0.319. Okay, so about a 31% chance. Okay, a little better than the 31% chance. All right, and the part D says, which of the events can be considered unusual? And then it says explain. Okay, so somewhere in the book it talks about how to identify unusual events. Okay, but it basically just says that an event is considered unusual, okay, if its probability is 0.05 or less. Okay, so if we go back and look at our answers, we want to see which ones have probabilities that are 0.05 or less. Okay, so answer to part C is too big, right? That's bigger than 0.05. Same with part B. Okay, so the only one that has a probability of 0.05 or less would be part A. Okay, so the event in A is unusual because its probability is less than or equal to 0.05. And that's the only answer choice that makes sense. Okay, so that completes question 5. Okay, I'm going to go ahead and skip over question 6 and go on to the next one. Alright, so question 7 says the accompanying table shows the number of male and female students in a particular country who received bachelor's degrees in business in a recent year. So we're going to complete parts A and B. Okay, so let's go ahead and click on the icon to view the table. Okay, and this is the table of data that we're going to use to answer the question. So part A says find the probability that a randomly selected student is male given that the student received a business degree. Okay, so these questions can be a little tricky, but they don't have to be. So if you look at our table, right, the given event is that the student has a business degree. Okay, so our table is divided into male and females, and then business degree and non-business degree, and then they have the corresponding totals. Okay, so the given event is that the student has a business degree. Okay, so we're only going to focus on this part of the table. Okay, so the numbers in this part of the table represent all those that have business degrees. Okay, so we're specifically asked to find the probability that a student is male given that they have a business degree. Okay, so this part of the table represents all the males. Okay, these numbers here. And then these numbers here represent those with business degrees. Okay, so you look for where the two events intersect in the table. So the events of male and business degree intersect in this part of the table, okay, which is this number here. So 181,573. Okay, and because we know that this particular student has a business degree, okay, we are restricted to the total of number of business degrees. So total number of students who have a business degree, which is 351,172. Okay, so to get the answer, right, we take the number of males who have business degrees, which is this number here, and then divide by the total number of students with business degrees only, so 351,172. All right, that's going to be your answer. So we can go ahead and put that in our calculator. So 181,573, okay, divided by 351,172. Okay, and that number there, so 0.517, will be the corresponding probability. So 0.517 goes in our answer box. Part B says find the probability that a randomly selected student received a business degree given that the student is female. So before we look at the table again, right, let's identify the event that is given. Okay, so the given event is that the student is female. Once again, we're asked to find the probability that the student received a business degree given that they are female. Okay, so the fact that the given event is female, right, we're focused on this part of the table. So all these numbers here represent female students. All right, we want to know the probability that the student has a business degree given that they are female. Okay, so you look where the business degree intersects with female in the table. So both those events intersect at this number in the table, so 169,599. All right, and we're going to divide that by the total number of students with the given event, so which is female, so total number of female students. Okay, according to the table, which is 1,066,996. So 1,069,996. So we divide that number, so the number of female students with business degrees, that number, divided by the total number of female students, which is the total number of students that have the given event. Okay, so go ahead and put that in your calculator, round to 3 decimal places, so it should be about 0.159. Let's go ahead and check our answer. and it's correct.